Hi guys, I welcome all the viewers in this video and my YouTube channel as well. So guys, I'm just continuing with the concept of N plus certification CompTIA, and I'm just going through with volume 1, and in this video I'm sharing and I'm talking about lesson 3. So guys, if you want to appear in the examination of CompTIA N plus, then please go through one by one all the videos and try to understand, because I have taken all the concepts in a very simple way, with very good examples how to understand it and how to prepare for this, and I'm sure this is going to be very helpful for you guys. And if you find helpful, please don't forget to subscribe to the channel, comment on this video and share this video and like this video. For that you just can go through this URL. This is my YouTube URL and this is blog as well. So guys, let me begin with what I'm covering in this video. So guys, lesson 3, which is known as network data delivery. Okay, so the main concept of this video is network delivery. We will understand in this, and inside that we will be having three topics. First topic is data addressing and deliveries. Okay, next one is network connection mechanisms, and third topic is reliable delivery technique. So each and everything has a separate concept, separate you can say the role, and we will understand each and everything one by one in this. So guys, the very first one is topic 1, topic A, which is data addressing and delivery. So first of all, we should understand what is data addressing and what do we mean by delivery. Okay, that is also known as data delivery only. So one of the first thing that must happen to ensure that a network request arrive at its intended destination is data addressing. The meaning is very simple guys. First of all, that network has to ensure that the destination where the data has to go, the network should be knowing where the data has to go. Okay, getting data packaged for delivery so it can be routed to its correct destination is the root of networking. So this is what we have. Why do we use root, and what is the you can say delivery of this packet? Once that package is ready, that network has to deliver it to the correct destination. Okay, in this topic we will examine how data is packaged and addressed so that it can be accurately delivered to its intended destination. So entire thing we will understand in this topic one by one. So first of all, we have to understand what is MAC address here. So guys, MAC address is nothing but it is a physical address. Okay, is a unique hardware level address assigned to every networking devices by its manufacturer. So it is a you can say just like one device, one address, and it is also known as physical address. Okay, and it will be unique. One MAC address cannot be assigned to two hardwares networking devices. MAC addresses are 6 bytes long. The first 3 bytes uniquely identified by the manufacturer and referred as organizational unique identifier. The remaining 3 bytes identify the device itself and known as the universal LAN MAC address. I will show you what does it mean. So this is what we have here, MAC address. Okay, so as you can see here, there are 6 bytes. Okay, 6 byte long. 1 2 3 4 5 6, these are the bytes. So these three first will be considered as organizational unique identifier, OUI, and the rest of three will be universal LAN MAC address. So we should be knowing it is a combination of two parts. One is OUI and second one is universal LAN MAC address and typical MAC address. This is known as MAC address. So even you can see on your systems, like if you go to property of a LAN card like this and details. So here you can find your MAC address. This is your physical address and that is also known as MAC address. Okay, and unique it will be. Or other thing, you can go to CMD, just type IP config slash all. So here also, oh, and hit enter. don't know why it is not coming, but we should come that information here also. So let me just put, okay, leave it guys. So you can say you can find this MAC address here also. Okay, and next thing, let me move to next one, network address. First of all, I told you about MAC address. Now I'm talking about network address. Okay, so what do you mean by network address here? A network address is a protocol specific identifier assigned to a node. So you can say it is a protocol specific identifier. Okay, and it will be assigned to a particular node. A network address typically includes two parts. One is to identify network, and second is to identify the nodes. Nodes means what? Host. Okay, a network address is typically a number and is mapped to MAC address by software running on the nodes. So network address typically will be a number, and it will be mapped with your MAC address by software running on the nodes. So this is what I'm talking about. This one is your network portion, and this one is your host portion, or you can say the node portion. Okay, and this is complete IP address 192.168.100.100. This is subnet marks 255.255.255.0. Okay, separate network from node. So even if you see here, I just now I told you here in this, where is that? Oh. So this is the IP address, and this is just you can say subnet marks. Okay, now let me move to next one. What is that? So I told you about network address. Now we will move to network name. What do you mean by network name? So guys, network name is a word or phrase assigned to a node to help users and technicians more easily recognize the device. So it is a name. Okay, nothing but it is a simple a name. So recognize and identify the name of the devices. And a naming service enabled by software running on one or more nodes map a network name to a network address or MAC address. So as you can see here, for example, I have just taken a very it's not cleared here. For example, Windows Server 2003 descriptive host name. This is name. Okay, host name of a system, or this is IP address. So a DNS network name, you can say like this. This name is mapped to this IP address. CMD, if you go to CMD and ping, let me ping, what should I ping here? Let me see what is name of my system here. IT-D0. So IT-D08. If I put this name, I will be getting a reply from IP address of this system. So it is coming from fast. It is showing MAC address only. So this is what I was talking about, MAC address. Okay, physical address here. It is not showing IP address here. So now next thing guys, here naming service. Naming service map network name to network address. Network name, I told you, network address. This is just a unique name, okay, or word, and this was your network address. There are many naming services in use, a few which are listed below, like DNS domain name service, NetBIOS, WINS. If we talk about DNS, so the naming service used on the internet and many TCP/IP based network. And if we talk about NetBIOS, then a simple broadcast based naming service. And if we talk about WINS, older type of naming service used in Windows based network. So it was developed earlier. There were certain challenges to use this one, so they developed DNS to avoid or eliminate this WINS. Packet, guys, very important here. Each and everything is about packet in this. So a packet, also called datagram, is a unit of data sent across the network. So that entire data will be traveling through this packet only, inside this packet only. In general, all packets contain three parts. So it will be having three parts. One is header, third one is data itself, and second one is data itself, and third one is trailer or footer. So it is a combination of three part. I will show you one by one in this. It is, in the simplest case, a sender transmit one packet and then wait for acknowledgement from the recipient as ACK signal and ACK signal. If the recipient is busy, the sender sits idle receive until it receives the acknowledgement from the receiving device, after which it sends the next packet. So this is a process. For example, one PC is here and one PC is here. I have sent certain data from here. So how much data it has received, it should acknowledge this PC, yes, I have received this much, so that the rest of can be transmitted from sending device. If it doesn't send this receiving device any acknowledgement, it will be on idle. So this is the concept of this. Throughput could be increased if data could be sent larger packet with the recipient sending fewer acknowledgement. The content of the packet depend on the network protocol is used. So I will show you a couple of things here. And what is that now? Packet contents. So what will be inside that packet? First one is header, I told you. Second one is data, and third one is trailer or footer. So what is that header here? So this is a part of that particular packet. First one is header, second is data, and third one is footer. If we talk about header, made up of preamble and destination and source address. So it will be containing like preamble, okay, destination, source address. The header describes the source and target of the packet, where it has to go. If we talk about data, the original data what we are trying to send. Third one, trailer or footer, an error detection code, which is EDC. So these are the three component or content of packet. We should be knowing each and everything, very important. Ethernet packet header contents. If we are talking about now Ethernet packet header content. So an Ethernet packet's header begins with an 8 bytes preamble. Okay, the preamble is standardized pattern of with that are receiving nodes used to synchronize timing so that it can properly read the rest of packet. So it is used to synchronize that communication or timing with the or between source and receiving device, so that it can read the data which has to arrive at. Following the preamble, the header contains the destination node 6 byte MAC address, following that is sending node 6 byte address. These address help nodes and other networking devices deliver the packet to its destination and provide the necessary information for replies. So guys, this is what I was talking about here. Okay, theoretical could be a little bit difficult to understand by listening, but we should have particular explanation like through any graphic and all. So we will talk about here. The header may contain other data such as bytes identifying the type of data contained in the packet. Okay, so it can have multiple information also with this header. So we will understand here. So guys, this Ethernet, I'm talking about Ethernet here. Okay, Ethernet packet header content. So what it will contain? First of all, destination address. This you can see here. Okay, these 6 bytes, 1 2 3 4 5 6. Okay, so an Ethernet header showing the destination address. These will be your destination first. In previous slide also I told you 6 or 8, 6. Okay, and I told you here somewhere this one 6 bytes. Now if we talk about source one, so again if you expand this one, Ethernet source address just below this one. So source address will be your 1 2 3 4 5 6. These 6 bytes will be your source address containing an Ethernet header showing the source address. This is how that Ethernet packet header contains information about data which is traveling and what will be inside that. Next thing guys, here Ethernet type, it will show you what type of protocol it is using. So as you can see here, IP version 4 it is showing. Okay, showing the protocol information as well. If you expand this or you just see or you just go just below down this one, so here it itself it can you can identify. So guys, here the topic is not over yet. We have one more small thing here, footer. Okay, we will understand here because I told you here it will have couple of things like footer as well, and this thing we will understand now. So Ethernet packet footer contains An Ethernet packet's footer contains the result of the mathematical operation performed on data. The sending node computer an error checking value of the data to be sent. Okay, guys, I will tell you only one thing here. I don't want to read this much information. So as you can see here, this information is showing here. This IP checksum is used for error detection and all, or if any error is going, or any error is there in that particular that inside that package, so they will rectify it. That is what this useful here. So if you want to find, you can find here like AA29 error checking value. Okay, it should be like this only. Now guys, topic A is over here. I'm moving to topic B, which is network connection mechanism. Okay, and in this uh, you have looked at how data is packaged and addressed for delivery before they can exchange packet. However, the two nodes involved must connect to each other. In this topic, you will examine the network connection mechanisms. So the first one is, guys, simplex mode. Okay, so simplex mode communication is one-way transmission of information. Basically, there is no return path. Okay, because the transmission operates in only one direction. Simplex mode can use the full bandwidth of the medium for transmission. So it is one to one, one way only. Okay, there is no two-way. So examples: radio and television broadcast and public address system operate in simplex mode. However, this mode is not used in networking. So it is not used in networking, but it is used in radio and televisions, because in radio you cannot speak with the that voice. Okay, and even in television, whatever we see. So this is what I was talking about. This is example of simplex mode here. So it is just one way. The transmissions are, transmitting the signals are coming from here, or this is your home. You are sitting here. Okay, you are staying here. So you cannot communicate back to here, this side. So this is known as simplex mode. Next one is half duplex mode. So guys, half duplex mode communication permit two-way communication. Okay, but in only one direction at a time. So in this, two-way is possible, but at a time only one can speak and one can receive the signals, or the communication can happen. When one device sends, the other must receive, then they can switch role to transfer information in the other direction. Half duplex mode can use the full bandwidth of the medium, because the transmission occurs in only one direction. So it is also one direction, but that communication or the device can use entire bandwidth of that particular medium. So this is what walkie talkie is a example of this half duplex. Okay, for example, this is sender, and if this is speaking, so at that time this will be silent, or this will be receiving that data. At a time we cannot, or both the device cannot speak, something like that. Okay, and if it is sending any data, then it has to be on a standby mode. So this is known as half duplex mode. Next one is full duplex mode. So full duplex mode communication permit simultaneous two-way communications. Okay, a device can both send and receive at the same time, and sending and receiving could occur over different channel or on the same channel. And generally neither mobile phone, generally guys, mobile phone is a full duplex. Okay, neither the sender nor the receiver can use full bandwidth. So here one part, like sending or receiving, cannot use full bandwidth of that media. Okay, it can be different, the amount of utilization of bandwidth of that particular media. Individual transmission, because transmissions are allowed in both directions simultaneously. So telephone system are full duplex devices. All person involved in the talk simultaneous. Many modern networking cards support full duplex modes. So this is what I was talking about, two phone, okay, or two mobile phone. Both the person can talk at the same time. Guys, next one is point to point connection. A point to point connection is a direct connection between two nodes. Okay, data transmitted by one node goes directly to another node. Or dial-up modem connections are point to point connections here. And this could be connected through any terminal also. So this is what I'm talking about. These are the terminals here, okay, and for example this is my server and this is my host. So this can be through one direct cable also, or this can be through uh, terminals. That is known as point-to-point connection. Now guys, multi-point connection, the next one is, so multi-point connections are connection between many nodes. Each multi-point connection has more than two nodes. I think the meaning is very simple here. And a signal transmitted by any device on the medium is not private, okay, so that the transmission will not be private. All devices that share the medium can detect the signal but do not receive it. So the receiving is not possible for all the devices, but they can detect something is happening throughout that media medium of that transmission. So multi-point connection are the most common way to physical connect a network, and physical versus star network are example of multi-point connections. So as you can see here, all these systems are connected through one cable, okay. This is bus, you can consider physical bus. Now this one is your receiving device, okay, and this is your sender. So what will happen, some data is coming from here and it is going to this side. This device is detecting that some data is going, but it will not receive because it is not participating in this. And even this is detecting, but it will not receive that data. That is known as multi-point connections. Next one is radiated connections. So guys, radiated connection or broadcast connection is a wireless point-to-point or multi-point connection between devices. So basically it is a wireless, okay. Wireless LAN, infrared and Wi-Fi network are all radiated connections. So if you have any wireless access point and user is sitting here, that is known as radiated. So the signal will be traveling, or that communication will be happening through wireless medium or media. Guys, next topic, what is connection service? So connection service ensures reliable delivery by detecting and attempting to correct transmission problems. So these are the services which plays very important role. As you can see here, or you can see, they will detect if there is a issue with that transmission, or if there is any issue they will try to correct it. That is the role of connection services. So there are three types of services here. First one is unacknowledged connectionless. So what will happen in this service provides no acknowledgement of successful transmitted data. For example, if you have two systems here, any data was transmitted from this to this. So in this unacknowledged connectionless, so there will be no acknowledgement from receiving device to sending device, yes, data is delivered or something like that. The application must provide its own reliability check. So whatever you are sending here, it should check by the system only, yes, it is reliable and it can be delivered without any issues. Simplex communication use this type of services. As I told you in previous slide, Simplex communication will use this kind of services. Next guys, next one is acknowledged connectionless. Okay, so node do not establish a virtual connection. In this there will not be any virtual connection. However, they do not acknowledge the successful recipient of packets. So again in this they do basically, okay, in this acknowledgement will be there. They do acknowledgement of the recipient of the packet. So this receiving device will send acknowledgement, yes, I have received the packet. And web HTTP communications use this kind of connection services. If you are using HTTP or HTTPS, in that kind of services, this kind of acknowledgement build or this service, connection service, will be playing role. Next one is guys, connection orientated. Okay, so nodes establish a virtual connection for the duration of the session. So for the transmission, both the nodes will establish one session for a certain duration, as long as the transmission is not completed. This connection service provide the means of flow control, packet sequencing and error recovery function. So during that session, this service, connection oriented service, will provide certain services or multiple services like flow control, how what will be the speed of data sending and what will be the speed of receiving of the data at receiving end, or how, if there is a issue in flow control, that how it should be managed, packet sequencing. So these are the other roles of this connection oriented service. Traditional non-web based networking application often use connection oriented services. So guys, here the topic B is also completed. Now moving to topic C, which is reliable delivery techniques. So we show how data will be packaged and how it will be uh, get ready to delivered or for transmission. Okay, so these are the all what we have spoken so far. Prerequisites to, you can say, before transmitting the data. So what will happen in this now? In term of network data delivery, you have identified two pieces of the puzzle: data addressing and network connection. How that connection will be establishing between two resources or two nodes, and how that data will be addressing to go through that transmission from source to destination. So we have understood two things. Now we will move to reliable delivery, how that will be delivering to that destination. So we have to focus on reliable, that delivery should be reliable. Okay, there should not be any problem. So we have to take care of lots of things here. Once you have the data properly packaged and addressed, and a functional network connection is established between source and destination computer, you are ready to transmit across the network. In this topic, you will examine the techniques to ensure make sure that the data is transmitted completely and accurately across the network. So this is what we will understand here. So first of all guys, error detection, because if the sending device is sending any data, there should not be any error in that data. Okay, so to understand that, to make sure that error detection how is useful, we will understand in this. Networking device should detect when error have been introduced into transmitted data and recover gracefully. So all the device should be capable to detect those things, like if any error is there uh, in that data which is transmitting throughout the network. Now sender should transmit enough data but do not too much data, so that the recipient neither sits idle nor is overwhelmed by data. So it should send the receiving the sending device should send the required data only. It should not send very heavy data or too much data, so that the recipient device can receive the data easily. It should not wait longer to receive the rest of data, or it should not have to worry about the speed of the data, how faster the data is coming, something like that. Okay, electronic interference, loose connections, substandards equipment and other factor can cause signals to be changed while data is transmitted. So these are the causes which can impact the performance of transmission of the data during the transmission from one place to another place or source to destination, like loose connections or electrical interference, something like that. Networking devices ensures reliable delivery by using detection and flow control. So there are two mechanisms. First one is error detection, and the second one is flow control, to avoid such things. So guys, now we will talk a little more about here. Error detection is the process of determining if transmitted data has been received correctly and completely. Okay, that is known as error detection. Typically the sender attaches extra bytes in the form of an error detection code, which is also known as EDC, to transmit data to indicate its original content. So they will add some extra bits, okay, in the form of error detection code. The receiver checks that EDC to determine if the data has been altered during the route. Okay, so this is what error detection plays very important role. They will add certain bits, and that receiving device will be checking this EDC, whether any data was altered during the transmission, any hacker did anything to that data, or any data was corrupted. So that check will happen here. Now what will happen if the EDC matches, the data is processed by the receiver. So for example 1 2 3 was added, so that 1 2 3 is okay at receiving end, so that receiver will accept that data and will be processed. If the receiver finds an error, okay, if that receiving end is finding certain of error, it requests that the data be retransmitted. So again it will send a request to sending device, please resend that data. Error detection can also include like correction component, error detection, and correction EDAC, which is also known as error detection and correction, where if an error is found in the data, it can be revealed by the receiver. So this is what the procedure here, guys. What will happen here? Data sent with, okay, the first one is here, data is sent with your EDC in footer. Okay, receiver generates an EDC and compares it with the one sent in the footer. So receiving end will check what was sent from the sending end. Okay, do they match? If it is matched, yes, data processed. Okay, if doesn't match, then no. Request data to retransmit. EDAC attempts to rebuild the data. So this is the process what I was talking about so far in error detection. Okay, this is error detection process takes place before or after or you can say the during of transmission of the data. So guys, one more thing here in this same error detection, one concept is called parity. Okay, very important. So parity operates on a word by word basis. Okay, so you have to be very careful about this one. The sender adds one bit to each word of the data and then transmit to the receiver. So in this, what happens, if sender is sending in a data, it will add one bit to each word of the data. Okay, then only it will send. The receiver compare the number of ones. I will show you one graphic here. So this will give you a better quality. So now that receiving device, this is your sender device, this is your receiving device. Okay, so for example, what I'm talking about, you can see here. For example, this is your data, so it will add 1 byte to each word. So it is adding like 1 0 1 0 1 0. These are the numbers added by the sending device. Now it is reached to receiving device, so it will check whether it is same or not, like 1 0 1 0 0 1 1 0 1. So it is 1 0 1 0 0 1 1 0 0. So it will check. If it is not same, then there is a problem with that data. It will request once again by please resend that data. So this is what I'm talking about here. Okay, so it should be equal both the sides. For example, as you can see here, 1 is placed at this place and 0 is placed at this place, so that data is not accurate. So this is called parity checking, is an error detection method. So there is a error in your data. Okay, so you have to resend. If a word is determined to be corrupted, so your data is corrupted because it got changed, the receiver requests that the data is retransmitted. So this receiving device will retransmit that data. Once again, receiving device will request to retransmit the data. Okay, so even and odd parity, there are two types of parity here, guys. One is even and second one is odd parity. So what will happen here, the receiver must be configured to use same type of parity checking as the sender. So at both the systems, same parity method should be enabled. Okay, parity checking can be implemented as either even or odd parity. So what is this even or odd here? With even parity, what will happen? If we are talking about even parity, the sender counts the ones. Okay, here I will show you this one. Senders count in a word of data and appends a 1 or 0 to the word to make the count even. So 0 will be your even and 1 will be your odd. So we will understand couple of things here. Internal computer parity checking. So guys, here for that there is a internal checking also. So parity checking is sometimes used internally within a computer itself. For example, memory chip, there are certain memory chip use parity bits so that the processor can determine if data in memory has been altered during storage. So there are certain technology available here. So I was talking about 1 and 0, guys. So these as you can see here, 1 is will be your odd and your 0 will be even. They will count like this throughout this parity check. Okay, and there should be, yes, definitely there will be there is a technology, as I told you, internal parity checking inside computer. So the processor can itself define if any data we are saving in the computer, yes, this data is not altered and this data is okay. So similarly guys, we have one more technique here, or service here, which is known as a cycle redundancy check, which is also known as CRC. Okay, uses a predefined mathematical operation to calculate a CRC code. So again, it is a error detection method. It attaches a CRC to block of data and transmit it to receiver end. So what will happen here? Again, same. If it is sending any data from here to receiving device, this computer, then it will attach the CRC to a block of data. You should be very careful here. It is a block of data. Okay, before it transmit that data to, or that packet to, sending device. The receiving node calculates its own CRC value for the data block and compare it to the transmitting CRC. If the value matches the receiving, assume that the data was unaltered during the transmission. So this is what I'm talking about. For example, again, two systems here, and this CRC is added throughout this transmission by the sending device. So again, it will check 1101, 1101, 2011, 2011, 110. So it should be equal, okay, as it was attached during before transmitting. So it will accept if it is same. For example, if you see here 0100, 0100, so it is okay. So this is what CRC we have for error detection. Now one more important thing, flow control. Okay, so flow control is a class of technique for optimizing the exchange of data between systems. Again, so optimizing the data exchange between two systems here. What does it mean, or how it is useful? I will tell you here. If too much data is sent at once, the receiving node can become overwhelmed, dropping packet that arrive too quickly to process. So what does it mean? For example, this is your sending device, okay, and this is your receiving device, and that certain data which was sent from here went very quickly to this receiving device, and it is not capable to handle that traffic. So in that condition, flow control manages that communication or the transmission of data. Okay, so there are certain techniques inside this also. There are certain different methods used to control that one. Okay, so for example, flow control is what? Buffering, basically. Okay, so in that condition, what will happen? This receiving device may drop certain packets, or miss certain data from that packet. So this is what the situation. So to avoid that, flow control is used. If too little data is sent, the receiver sits idle. If less data is coming, so it will wait for the rest of data to come, and it will be idle, okay, until it has arrived from sending device. Buffering and data flow are two flow control techniques. So buffering, we generally stream any video and all. That time certain data came, but we cannot play the video, we need to wait for certain time. That is known as flow control. Okay, so guys, we have to understand couple of things here. Example of buffering. Buffering is a flow control technique in which received data is stored in temporary high speed, okay, memory location called buffer until the main system component are ready to work with the data. So simple thing, I told you, while we buffer certain videos and all, movies and all, it doesn't come in one shot if you don't have good speed. So you need to wait, and that will be stored in temporary location. That is known as buffer. In a networking situation, the network card itself handles buffering. So network card, LAN card will be dealing with that kind of situations, okay, so that this system CPU does not have to become involved in this. So your LAN card should be capable to manage those things, but by default they do it. Buffering is also used when reading information from disk of RAM, in which case the buffer is more often called cache. So it is also known as caching. Okay, a cache controls a specialized processor chip manage caching, so that the CPU doesn't have to worry about it. Even with high speed buffer, data can sometimes arrive too quickly to handle. The situation is called uh, flooding. Okay, you're arriving I mean that sometimes the data is coming very quickly or very high with very high speed in your system. I mean that receiving device is not capable to handle that. That is known as flooding. So buffering is little bit okay, but it is too much quickly. That is known as flooding. To avoid flooding, receiving device typically send a sequence signal to sender when the buffer is approximately 75% full. So to avoid such things, what happens? That sending device or this receiving device will send certain signals. Yes, I am 75% full. Upon receiving a sequence signal, the sender will slow or halt further data transmission until the receiving has caught up. So this is how uh, certain things can be controlled, like flow control, okay, through using caching, buffering. One more thing here, guys, we have data window. So what do you mean by data windows here? In the simplest case, a sender transmits one packet and then waits for acknowledgement from recipient and acknowledge signal. If the recipient is busy, the sender sits idle until it receives the acknowledgement from receiver to send next packet. So guys, in this, throughput could be increased, in data could be sent larger package with the recipient sending fewer acknowledgements. Okay, so what will happen here now? Data windows provide just such a flow control technique. Once again, it is a flow control technique. Multiple packets are sent as a unit called block or window. So multiple packets uh, can be sent or are sent as a unit called block or window. The recipient acknowledges each window rather than each packet. Okay, so now it will acknowledge as a window, not as a packet, resulting a high throughput. So you will get high throughput throughout if you are using this windowing. Okay, so this is what I'm talking about here. Data window, for example, you can see here. Okay, if you are sending one, so it's okay without data window. This one acknowledge delayed if receiver busy. So in this will uh, there will be a little delay in receiving acknowledgement from receiving device. Now if you put window, okay, you have 1, 2 and 3, you made it like 4 10, you added something inside this, you made it as a window now or block. So with data window, what will happen? This packet and this acknowledgement both can go at a time. So this is how data windows work. Now we will move to the next one, and guys, in this much only. Okay, and if you find this helpful, please don't forget to comment, like this video, share this video, and subscribe my channel. And thanks for watching for this video, and wait for my next video. In next video I will be talking about the fourth lesson, and till then, bye bye.